So, hello everybody. Good evening. Okay, welcome to this interactive session on with the week 7's content. So, in the week 7, Sir went over virtual function tables, typecasting, and cast operators, specifically the C++ typecasting operators, and he also went over multiple inheritance. So, these are some slides from Sir's PPT. So, uh, like as we all saw in the previous week, so when a class defines virtual functions, so when a class defines virtual functions, then we saw that the the method which is run, it is of the correct object. Like if there is a if there is a inherited if there is inheritance, like if there is a base class and a derived class. Now if the same if the virtual functions in the base class have been overridden in the derived class, and then we take a pointer of the derived class and we cast it to a base class pointer, and then we call a method on the base class, we saw that the uh, actually the derived class's function is run. So what mechanism is used to like how does this system work, and what is the mechanism? So that is implemented internally using virtual function tables. So this is not something that we have to do. This is done internally by the compiler. So VFT pointers are used at runtime to invoke the appropriate function implementations. uh, because see, in dynamic polymorphism, at compile time it is not known whether the base class function will be called or the derived class will be called, and it is also not known that which derived classes function will be called. Now VFTs are class specific, so it is not object specific, so all of the objects will share the same VFT, and the VFT carries runtime type information of objects. Okay, and then he went over the C++ typecasting operators. Now, as we all know in C, if we have to explicitly cast something, we write in brackets the name of the type. Like we can write here int, and then we can put a double value. This will be typecasted to an integer. So these typecasting way is not recommended in C++, because in C++ there are better typecasting operators which do a lot of checks to make sure that what we are doing is correct or not. Like for example, the like C++ has four typecasting operators. So the first one is the const cast operator. This typecasting operator allows us to override the constness of a variable. So so the const cast operator is a way to, like if we have a variable which is const, then we cannot modify it. But const cast operator can be used to override that and modify the variable. Next we have the static cast operator. So the static cast operator does the usual kind of casting that we know. So if we are writing this expression in C, then the corresponding expression in C++ will be static cast int, and then you can write 3.5. So all of these operators, they are templated functions. So as you can see that we have to templated functions means that we have to specify the type. Like here you can see we are specifying the type in to which function do we want to convert, and the operator is actually a function and it accepts an argument. So first we, in the template arguments, we specify the target type, okay, like into which type do we want to convert, and in the function argument we specify the source variable that we want to convert. So the static cast is the normal kind of casting. uh, it is also non-polymorphic, so it is done at compile time. Now one advantage is that static cast allows us to specify user defined conversions, uh, like uh, like let's say we have a custom class called a, and we wanted to convert an integer into an a, like so. uh, Now this won't be allowed in C style casting, but in static casts we can specify a custom constructor to create an a object out of an integer, and then we can use the user defined functions to perform the cast. Now a reinterpret cast is used for pointer types. It is used to cast between unrelated pointer types. So the important thing is that it is used to cast between unrelated types, and or pointer and an integer. So now one important thing which was highlighted in the slide is that usually reinterpret reinterpret cast things, they are very low level machine code, so that kind of functions are usually not portable. Like reinterpret cast means it interprets the binary digits of a variable in a different way. Like if we have some object, it will have some, if we have some object like a, it will have some binary data. Now with reinterpret cast we are interpreting the same binary data as another object. So obviously your a and b, it, like if they're unrelated then there is no match, and a, like if a is a valid object then b might be completely gibberish. But sometimes in low level code it is required, or it is helpful to do that, but usually such kind of code is machine specific. Like one example would be serialization. Like if we have an object called a and we want to store it to a file, then we will have to convert the binary data of a into a string, and then we'll have to save it. So we'll have to reinterpret a as a string. So that is one application. Next we have dynamic cast. So dynamic cast is like static cast, but it is used when you are converting from a base object to a derived object. Uh, if you have a base object b and you want to typecast it into a derived class object, then we use the dynamic cast operator. Why? Because the dynamic cast operator checks whether the pointer actually refers to a D type object or not. Your static cast does not perform this check, and uh, static cast does not perform this check, but the dynamic cast, it performs this check to make sure that the conversion is valid or not. If it is valid, it does it, and if it is not valid, then it returns a null or it throws a exception. Okay, any questions? Okay, then let's continue. Next, sir went over multiple inheritance. So multiple inheritance basically means that one derived class object, this is the derived object, it inherits from two base class objects. So here is a base class object 1 and base class object 2, and this is the syntax. So class ta, inherits from student and faculty. So we separate the classes with a comma. Now what does this mean? Like we can write this line, but what does this mean? Um, this means that all of the data members of the student class will be inherited into the TA class, and all of the data members of the faculty class will also be inherited, and all the functions will be inherited too. So the TA class will contain all the data members of student, faculty, and all the functions of student, faculty. Now of course when we are doing this, then there is a scope of name clash. So in the student class we might have some variable called x, and in the faculty class also there might be some variable called x. So when we do that, it is not possible to disambiguate between those two variables. So for that purpose we'll have to explicitly refer to the class name. Like in the derived class, if there is a clash, we will have to use base 1 colon colon x or base 2 colon colon x to differentiate between the two x's. Okay, any questions till now? Then I'll continue. So the first question is this. Uh, this is some code is given, and we have to fill in the blank at line 1. So this is line 1. We'll have to fill in the blank such that the program will print name colon Samir. So first try it on your own, then I'll say. Okay, okay, let's do it. So as you can see, there is a class with a string name, and there is a constructor with a default argument. Like we specify the default value of the name, which is unknown, and we set the data member to this argument. And then there is a member function called update, which takes the string na. Now note that it is marked as const, which means that this function is not allowed to modify the any of the data members of the class. So it is not allowed to modify the data members. We also have a show info function which is also const, and hence it is not allowed to modify the class. Now you can see that the show info function, it does not modify the class, it just prints it. Next, in the main function we are constructing a const object of employee type, and we are giving it the name Sam. Then we are calling e dot update Samir, and then we are calling e dot show info. Now e dot show info prints out the name of the employee, right? So ideally it should print the Sam name, because it has been initialized with it, and the employee of, like, the e object, it is const, so it cannot be modified, so it should print Sam. But now we want to update it. So how do we update it? We'll have to, so here you can notice that we are updating a const object, so we are violating the constness. So for that purpose we'll have to use const cast. Okay, uh, so in this place we'll write const cast employee star this. Now since our object is const, the type of this will be employee star const this. Okay, so this is the type, and we are casting it to a employee star object. So we are removing the constness. This can only be achieved with the const cast. And after we have this employee star pointer, we can access the name part and we can set it to another value. There is there is another way. We can use the C style way also. Wait, we can use the C style way also, which is employee star this. Now again, see, the type of this is employee star const, so we are casting it to an employee star object. So we are removing the constant. Any questions on this one? So the answers here will be A and D. Okay, then let's continue. So this is the second question, and there is this code segment, and we'll have to fill in the blank at line 1 such that the program will print 6. Anyone? Okay, then let's continue. So here you can see that there is a global function called increment, which takes a integer pointer and it increments the integer pointer. And in the main function we have x equal to 5, and we are setting the we are creating a integer pointer and we are setting it to the address of x. Note that here the pointer is a constant. So constant pointer means that we are not able to modify the variable it is pointing to. Next we are passing this x to the increment function. So it should increment it like x should become 6, and then when we print it 6 should be printed. But the problem here is that our pointer is a constant pointer, so we cannot modify it. And as we saw in the previous slide, when we have to remove the constness we use const cast. So here the answer will be A. Static cast and dynamic cast, they will not permit it, and reinterpret cast will also not permit it. Now can anybody tell me what is another way of doing this? Like what is as we saw in the previous slide, there is another way to do this also. So what is another way to do it? Anyone? Yes, Arjun is correct. Arjun is correct. We can also cast it in the C style way. We can write in star and the variable. So in star x. No, sorry. In star PTR. This will cast PTR to a normal value. So any questions? Okay, then let's continue. So here we have a code segment with various classes and various virtual functions. So what will be the virtual function table for class A3? So this class. So what will be the virtual function table? So try it on your own.
Option A.
Yes, yes, option A is correct. So, so here you can see that class A1, it has a virtual function f. Then class A2 inherits from A1 and it has a virtual function g and also I. And then class A3 inherits from A2 and it has a virtual function h. So let us in fact let us make the virtual function tables for all of the classes. So first we have this hierarchy. So we have this hierarchy. Now consider the A1 class. Here we have only one function f, one virtual function. So your A1's wait. So your A1's VFT will be A1 colon colon f A1 star const, right? It will only have one function because there is only one virtual function. Now let's go to A2. So since A2 inherits from A1, A2 will have an f function of its own. In addition, it will have functions g, I. Note that h is not a virtual function, and also note that in A1 we have a g function, but it is not a virtual function. Now see for the f function, A2 has not overridden f, so in the VFT, for f it will still point to A1's function. Okay. Okay, so f is done. Now g and I, they will be of A2 class. G and I will be of A2 class. Okay, and your h is not a virtual function, so h will won't be in the VFT. Okay, and finally in class A3, we are making h a virtual function also. So your A3 is VFT. So wait, we are overriding G here, as you can see. Okay, F we are not overriding, so F will stay the same. Next, we are overriding G. G is being overridden, so this will be replaced with A3's G. Okay, and H has also been declared as a virtual function. And I we are not overriding, so I will remain A2. So as you can see, this is the VFT for A3. For F we have A1, for G and H we have A3, and for I we have A2. And this is matching with option 1, option A. So for F we have A1, for G and H we have A3, and for I we have A2. So anybody has any questions on this? Okay, then let's continue.
Sir, so can
Yes,
I ask one
yes,
question?
yes, sure.
Sir, we are overwritten G, void G function.
Yes.
Now, if we create a
Uh,
new object and
wait,
if it
wait,
is inheriting from A3,
wait. We have
A3,
overwritten G in which class? A3.
A3.
Okay.
Hmm. If we create a new class which is inheriting from A3,
Uh,
will G function act as virtual or not?
yes. Once
Oh,
see in your inheritance, okay, once a function has been declared as virtual, it is always virtual. So if
okay,
you
thanks, sir.
declare something as virtual here, wait,
Hmm.
then in A3 also it will be virtual. Okay, and everywhere, like even if you don't override or anything, it will be virtual.
Okay, thanks, sir.
Okay. So any other questions? Okay, let's continue then. So this might be, wait, okay. So this question is that how many virtual tables will be created for the following class hierarchy? So how many VFTs will be created?
2. So what two
Yes,
virtual table will be created?
yes. Okay. So Arjun is correct. So there will be two virtual tables. Now this is a pretty easy question. So the class hierarchy is like this. We have A, then B inherits from A, and C also inherits from A. Okay, and D inherits from B and C. Okay, so this is the class hierarchy. Now note that in class A the function f is not virtual. So here it's not virtual. There are no virtual functions in A. Okay, so A will not have a VFT. Next come to class C. So C, as you can see, it inherits from A, and it adds another function called G, and G is also not virtual. Okay, G is also not virtual. So again, our class C has no virtual functions. So A has virtual function. Uh, A does not have any virtual function. C does not have any virtual function. Okay, and next we come to class B. So B inherits from A, and it converts f into a virtual function. So our B will have one virtual function. So all of these have zero VFTs, and I mean they have zero virtual functions. So when we have zero virtual functions, we have no VFT. B has one virtual function, so it will have a VFT. Then we come to D. Now since D inherits from B, so automatically D will inherit all the virtual functions, right? So D automatically will have virtual function f. So D will have a VFT. Okay, so finally we have two classes which are VFTs, B and D. Okay, any questions? Okay, then let's continue. So in this question there are two classes and they are asking which of the typecasts are permissible. So which of them are allowed? Okay, then uh, let's continue. So here we have two classes. Here we have two classes, st1 and st2. Okay, and now note that they are not related in any way. So they are not inheriting each other. They are unrelated classes. Next we have your st1 star and st2 star pointers. Okay, so these are pointers of pointing to st1 and st2 objects, and the question is that which of the typecasts are permissible. So the first one is static cast. Now, as we know that static cast does not allow typecasting between unrelated classes. So these are both are pointers, right? So here we are trying to convert the s1 pointer into a s2 pointer, okay, and that is not allowed with static cast. Actually, that is only allowed with reinterpret cast. Only reinterpret cast can cast between pointers of unrelated types. So your static cast, it's not allowed. Dynamic cast also not allowed. Reinterpret cast is allowed, and const cast is also not allowed. So const cast is only used for removing removing or adding constness. So const cast is used for modifying constness. So that will of course not be allowed here because there is none of the variables are const. Even the target type is not const. And your static cast and dynamic cast, they're the normal kind of cast. So they don't allow unrelated types, modifying between unrelated types. Only the interpret cast allows. So any questions on this one? Okay, then let's continue. So this is the question, question number 6. This is the code segment, and you have to predict that what will be the output. Anybody? So in this question we have a class base with a virtual destructor. Okay. Now can anybody tell me why the destructor has been made virtual? Because like it seems that the there is no need to make it virtual, because in the derived class we are not overriding or doing anything. So the destructor has been made virtual only because in the code we are using these type id functions. So we are using these type id functions, and the type id function only works with uh, polymorphic data types. So if we did not have any virtual function in the classes, the class would not be a polymorphic type and the type id functions would not work. So this is a trick. Like if your function, if your class does not have any virtual function, okay, and logically also you don't need any virtual function, still if you want it to be polymorphic, if you require it to be polymorphic, what you can do is make the destructor virtual. Okay, now let's proceed. So here we are here we are declaring a b variable which is of base type and d variable which is of derived type. And now uh, then we are defining some pointers. So dp star is a pointer which is pointing to d, which is derived type, and bp star is also a pointer which is pointing to dp. Okay, so here you can see in the previous line dp is a of derived star type and we are setting it to bp. So uh, so it is being implicitly casted. The dp derived star pointer is being implicitly casted to a base star type pointer. And then we also have dpp, which we are setting it to, like we are casting it using the c style cast, and we are setting dpp to dp. And as we saw previously, dp is already of derived type, so nothing actually changes. dp and dpp are the same. So I will here draw a diagram here. So here we have one object which is which is b, which is of base type, and here we have another object which is derived and it is of, like it is d and it is of derived type. Okay, so the first pointer is dp over here. So dp is pointing to this. Next we have bp, which is set to dp, but it is of base type. So your bp is of base type but it is pointing to d. Next we have dpp, which is equal to dp only, so dpp is the same pointer as dp, and the type is also same, it is pointing to the same location and the type is also same. So after we execute these four lines, the situation is like this. Note that there is no pointer which is pointing to the base class. Okay, any questions up till now?
No, sir.
Okay, okay. Now, what does this type ID function do? Does anybody know what does the type ID function do? So the type ID function, it returns a object. It returns a object which is of type info type, and it contains information about the type of the object. Okay, so if we put some value like x, then the type info object will contain information about the type of x. Now one function of this, like this is a class. Okay, so this is a class. One of the member functions of this class is the name function. So the name function, it returns a string which is a human readable value of the type. So now this is compiler dependent. Okay, if you run it on G++, you will get some value. Like suppose our x is of this base type. Okay, suppose we have base suppose we have base x, and we are calling type id. It will return this type info object, and then we are calling name. This will give a string output. Now you might expect that it will give output like this base, but it might not give this output. It will give some other out it might give some other output also, which is compiler dependent. Okay, it is compiler dependent, but it is consistent. Okay, so if you have a base type object, it will always give some value. Maybe it will give maybe it will give base 1. Okay, if you have a base class object, the string might be base 1, but it is consistent. Like if you have some other variable also which is of base type, it will also give base 1. Okay, but if you compile it using some other compiler like ms Visual Studio, okay, msvc, then it might give some other string, but there also it will be consistent. So you can use this function to check types in runtime. Okay, yeah, during runtime you can check the types, and uh, you can take some action based on the type. Like if you get some object which is of some type, you can do something. If you get which some an object which is of a different type, you can do some other action. And one thing is that this type of id object, uh, it works in runtime, and it is polymorphic. So it is polymorphic in nature, which means that it means that it checks the actual value of the object. Okay, not the type of the pointer. It checks the runtime type of the object it is pointing to. Okay, so now we'll try to answer it. So the first question is that is the type of dp equal to the type of bp? Okay, so as we can see here, I'll draw a dotted line. As we can see, your bp is a base. This is base star, and both of these are derived star. So as you can see, bp is a base star and dp is derived star. So their types are not the same. So the first one will be 0. Then we have this. So type id star dp and star bp. So it is asking us to compare whether star dp and star bp are the same type or not. And remember that star, here star means dereferencing or operator, so it will refer to the object. So from this diagram you can see that BP points to D and also DP points to D. So both of them point to the same object, and it will infer that both of the object is same. Okay, the object is same and it is actually of the same type only. So for the second query, the answer will be 1. Okay, since they're pointing to the same place. Okay, now we come to the third question. So the third question asks us that is the type of BP and the type of DPP same or not? Now this is actually same as the first one, because as you can see DPP and DP, they are the same thing. Okay, so the types are also same and they're pointing to the same place also. So this is this is exactly the same as the first one. Okay, this is exactly the same as the first one. So in the first one we saw it was 0, so it will be 0 again. Then we come to the last one, or the fourth one. As you can see, this is again same as the second part, because DPP and DP, they are of the same type and they are pointing to the same object also. Okay, so the in the last case also it will be 1. So A will be the correct choice. So any questions on this one? Okay, then let us continue. So this is the next question. Here I did not have space to include the options, so you have to say what is the output. So please try on your own. Okay, so so in this question we have a class base which has a virtual function f. It has a virtual function f which prints base. Okay, so this is used to identify the class. Next we have another function, another class derived, which inherits from base and it overrides the function f and it prints derived. So the function f is used to differentiate between the two classes, base and derived. So in the main function we'll be doing all this. So this will be used to differentiate between them. Okay, now in the main function we are creating two objects, OBB and OBD, of base and derived types respectively, and then we are trying all these casting operators. So the first one is we are trying to cast OBD to a base reference BA ampersand. Okay, wait 1 minute. Hmm. Okay, so we are trying to cast OBD to a base reference OBD. Now OBD is of derived type. Okay, so and it inherits from base. So the when after casting, the object will be of base type, right? So now when we call array1.f, it calls the virtual function of the base class. Oh no, sorry. So this is a base reference, but the actual object is OBD, right? So we have OBD which is of derived type and array1 which is of base type. It is a reference to OBD. Okay. Now since your f is a virtual function and array1 is actually pointing to a derived type object, it will call the f function of the derived type. So in the first line the answer will be derived. Okay, next we have in the second case. In the second case also, in the second case we are using dynamic cast. So it is everything is else is same, OBD base reference, but we are using a dynamic cast. Now a dynamic cast, it what it does, it just checks whether the conversion is valid or not, whether it is a correct conversion or not. So if we look at the class hierarchy here, the generic class is base and the derived class is inheriting from it. So the specific class will be derived. So derived is a base. So when we cast derived to a base, it is a valid cast, right? Because there is no problem in casting derived to a base. Derived has a base. So every derived object has a mini base object inside it. It will have a base object inside it, and on top of that it might have some other data members or member functions. So when we cast derived to a base object, this small base part is taken out of it. So this casting is valid. So dynamic cast won't cause any problems. It will give the same result. Now once we Now once we get this array2 variable, again since array2 will be pointing to the same object, and since f is a virtual function, for the second case also the output will be derived. Okay, now we come to the third one. Okay, so in the third case we are converting OBB, which is of base type, we are converting into a derived type reference. So OBB, remember OBB is of a base type, and we are converting it to a derived type reference. Okay, now this type conversion is actually, it is probably not correct to do. Okay, if you have to do it, then you should think twice, or you should reinspect your code. This is probably not correct because it does not make logical sense. Okay, if we look at the previous diagram, so every derived type object has a base type object inside it. Okay, but the converse is not true. If we have a base type object, if we have a base type object, it does not contain a derived type object, and nor is it surrounded by a derived type object. Okay, so the base type objects might not be surrounded by the derived type objects. So when we convert these derived type object to the base type object, this conversion is valid because you can take the mini base object out of it. Okay, but when we are doing the opposite, this conversion is actually not correct because it is missing information which would make it of the derived type, right? It does not contain all the extra data members and member functions. So this is logically not correct. But the static cast operator, it allows you to do it in case you have something else in mind. If you have something else in mind, then the static cast operator will allow you to convert it. Okay, but you should probably double check or check whether you can do it in some other way or not. So anyway, once we perform this cast, we have RB1, which is of base type, but it is wait, which is of derived type, but it is pointing to a base type object. And now we are invoking rb1.f. Now since the object is actually a base type object, it will invoke the f function of the base class, and when we do that, we'll get base in the output. Okay, and now coming to the fourth one. In the fourth case, as we saw over here, converting from base to derived is probably not right. So this is the difference between static cast and dynamic cast. Static cast does not perform this check. It will allow you to do this conversion. Okay, it does not perform this check. But dynamic cast, it will perform this check to, like, it will make sure that whether this conversion is a valid or logical conversion or not. So since this is not a logical conversion, dynamic cast will throw a exception. Dynamic cast will throw a exception called std colon colon bad cast. So if you people know exceptions, then what will happen is that the program will continue, like it will execute up to this line. Then when the exception is encountered in the cast, it won't execute the lines after that. It will jump to the catch block. So that is why you can see that in the question, this section has been put in try catch blocks. So like if you don't know try catch blocks, wait, so first let me discuss the output. So Therefore, the output will be derived base and std bed cast. So try catch blocks are used to handle exceptions in the code. The general syntax is like this. Okay. Now, what are exceptions? Like while running, if the program encounters a runtime error, like let us say you tell the program to read a file, but the file does not exist, or you tell the program to, by mistake, you tell the program to divide by 0, or let's say you need to connect to the internet, but there is no internet connection. So in that case, it's a runtime exception and it cannot be predicted from beforehand. Like while compiling, you cannot make sure that all the files of the program will be there. Okay. And you also cannot make sure that internet connection will always be there. So there are some exceptions which cannot be, I mean, there are some failures which cannot be caught in compile time. They are runtime errors. And try catch blocks, so compile time errors, they can be handled by the compiler. Okay, so the program won't compile if there are compile time errors, but runtime errors cannot be caught by the compiler. So try catch blocks are used to handle them. So in try catch blocks, you write the problematic pieces of code in the try block. Like you write those pieces of code. If you don't give the try catch blocks, when there is an exception, the program will crash. It will crash, or it will quit. Okay, or it will be terminated by the OS. So it is better to at least do something rather than crashing. Okay, like as you know that when we are trying to do something, when we are trying to do something on the computer, and there is a and then suddenly the program crashes, and we don't know what caused it or how to rectify it or why it crashed. So that is very frustrating, and it is not a good experience for the user. So this mechanism is used to prevent the crash. We put a problematic pieces of code in the try block. When the suppose this line causes a runtime error, okay, this time tries to open a file which is not present. So the program, like the OS, will jump from this line to the first line of the catch block. Your catch block will also have some blocks of line to handle the error. So the OS will jump from this line of code to the first line of code in the catch block. Okay, and in the catch block you can tackle that error. Like you can if the file does not exist, you can inform the user. You can say that the program needs this file to function, but the file does not exist in the correct location. So please do something, like please download the file, or if it is possible to self correct, then it you might be able to self correct it also. Like if the file does not exist, maybe the program itself can download it from somewhere. So in that case, you will download it in the catch block. Now the catch block, it accepts the argument e. Okay, this argument e, it is of exception class. Exception is a class, and this e is of exception type, and this e contains, e variable will contain information about the error which caused the crash. Okay, so the e object will contain information about what caused the crash. So you can print this. Okay, if you write e dot what, it will give a string representation of the exception, like a human friendly readable message, and you can print that to the screen. So in this code you can see that dynamic cast will throw exception if there is an invalid cast. So that is why this piece of code is in the try block, and then in there is a catch block to handle this. So it gets this exception object, and it prints e what. So this will print the error message. So without these try blocks, the program would print these three values and it would crash. But with this try catch block, it will print the three values and then it will print std bedcast. Okay, any questions on this one? Okay, then let us continue. So this is question number 8. Here again we are basically doing the same thing. We have some classes and we are testing out various kinds of casting operators. So please try the question on your own first. Okay, so let us continue. So here we have three classes A, B, C, and again you can see in class A the destructor has been made virtual. Why is it so? Because again your this dynamic cast object, it works with polymorphic types. So to make a polymorphic type, the destructor has been made virtual. Okay, and now the class hierarchy is like this. We have A, and B and C, they inherit from A, like this. Okay, next we have two objects, obj A and obj B. This is of A type and this is of B type. In the first line we are casting pointer of like the address of objb. So this will give a pointer, right? Ampersand objb will give a B star pointer, and then we are trying to cast it to an A star pointer. So static cast does not permit casting between unrelated types. Okay, if there is no relation between the classes. But here you can see that B and A, they are related. Okay, so static cast will allow this conversion, and we will get an A star pointer which points to the same object. Okay, again let me make that diagram. So we have obj A and obj B. Obj A and obj B. So PA is a is of type A, but it points to B. Okay, and now after this we have this line. So this line is basically used to check the validity of the pointer. If the casting is not successful, then the operators, they will return a null value. So you can check for it. If you write PA, if you compare PA to null, and if you find that it is true, then it means that the casting was not successful. But if the casting was successful, then there will be a memory address in it. So in this case, since it was successful, this part of the code will be executed, and so the first answer will be cast 1 valid. So the cast 1 is valid. Now one thing, this is, if anybody is not familiar, this is a ternary operator, which is a shorthand for if else. So here we write a expression that, here we write our condition that we want to check, and this part is executed if it is true, and this part is executed if it is false. So this is a shorthand for if else. So in this line we are checking whether this statement is true or not, and if it is true, so this is the true part. True part will print invalid, and the false part will print valid. That is why we are checking null. Okay, so if the pointer is null, if it is true, then the pointer is invalid, so first part will be printed. But if the pointer is not null, then the pointer is valid, so that is why the second part will be printed. So for line 1, uh, your cast 1 is valid, so this is what will be printed. Then we come to line 2. Here we are static casting PA to a B star type pointer. Okay, if you remember, PA is of type A star, and now we are casting it to a B star type object. Okay, so A star type pointer, we are taking it to B star object. So what will happen, like will this be allowed or not? So static cast allows us to typecast the pointers as long as the classes are related. Okay, so as long as they are related, so since this is a related cast, related classes A and B, so cast 2 will be valid. Okay, this would not be allowed if this was a dynamic cast. Okay, because as we saw that converting from derived to base class is a logical conversion. Converting from base to derived is not logical, and dynamic cast does not allow it. So our second line is done. Then we come to the third line. In the third line we are dynamic casting. Okay, so be careful. We are dynamic casting to C star type, and it is new A. New A will return a pointer of A star type, right? New A will return a pointer of A star type. So let me write here. So in the first case we are converting B star, wait a minute, valid, invalid, valid, invalid. No, sorry, that won't be the case. So, yes. So, cast 2 is valid. Now, in case of cast 3, uh, so in the first question, in the first line, we are converting B star pointer to A star pointer. In the second question, we are converting A star pointer to B star pointer. In the third one, we are converting A star to C star. And in the fourth one, we are doing B star to C star. Okay. So this new A line, it will give a star pointer, which we are trying to dynamic cast to a C star pointer. So A to C, we are going from base to derived, which is not allowed by dynamic cast. So cast 3 will be invalid. Okay. And in the fourth line, uh, ampersand objb will give a pointer of the B. It will give a pointer of B star type, and we are dynamic casting it to C star. As you can see that they are not uh, children or parent of each other, so they're in a way unrelated. So cast 4 will also be invalid. Okay, so this is the answer. Any questions on this one? Okay, then let's continue. So this is a code segment is given here, and we have to say what will be the output. Okay, then so in this question we have class B with one data member A, and then we have a constructor B which takes X and it sets the value of A to X, and then we have a get function which returns A, and we also have a set function which sets A to X plus 1. Okay, now we have a derived class D which has a data member B. Now remember that since it is deriving from B, your class D will also have a data member A which it inherits from B. Then in the constructor, we have a constructor which accepts two arguments x and y. It passes x to the B class and it sets this small b to y. So after the constructor is called, your A will be set to x and B will be set to y. Okay. Then we have this function called change, void change, which takes the integer argument c, and it does this casting, but ultimately it calls this function. Okay, it calls b's set function. It calls b's set function, and as we saw that the set function, it sets a to x plus 1. So this line, it sets a equal to c plus 1, something like this. Okay, a equal to c plus 1, it does something like this. Next what we do is we do b equal to c plus 1. Okay, and then in the print function we call b colon colon get, and then we also print the value of small b. Okay, like for now just ignore this casting, then we see what happens with the casting. So if we did not have the casting, the first line would be a equal to c plus 1 and the second line would be b equal to c plus 1, and you can see b colon colon get, it prints a, like it returns a. So this line is equivalent to c out a and then space and b. Okay, so now we'll see, go to the main function. In the main function we construct a object small d which is of capital D type with the values 10 and 20. So as we saw, when we call the constructor, this runs. So your a is equal to 10 and b is equal to 20. So a equal to 10, b equal to 20. Next we are calling small d dot change and then 7. Okay, and right now I'm ignoring the cast. So if I ignore the cast, then a equal to c plus 1 and b equal to c plus 1 and c is equal to 7. So c is equal to 7. So a equal to c plus 1, b equal to c plus 1. So a will be 8 and b will also be 8. Now when I call the print function, a and b will be printed. So our output would be 8 and 8. Okay. So this is what would happen if the static cast was not there. Now let us include the static cast and see. So we are static casting this pointer into B type. Not sorry, not this. We are static casting start this into B type. Now as you can see, this is in the D class, right? So this is written in the D class. So in this class, yeah, this pointer will have a type of uh, D star const. D star const. Okay, and after this will be written. So this is the type and this is the variable name. Now when we do star this, okay, sorry, this is that. Now when we do star this, it will return a D object. Okay, it will return a D object. Now we are static casting it to B. So now this becomes a B object. But here the problem is that when we do static casting, a new copy is created. The same object is not modified. So suppose let us look at a different example. If we have int x equal to 7 and then we write double y equal to static cast double and x. Okay, so let's say that we have written these two lines. Okay, so after the lines are run, okay, I can still use x, right? I can still, if I print x, I will get 7, and x will be a integer variable. Okay, so after these lines are run, I can still use x, but it has been already been casted to a double. So how does this work? So static cast, what it does is it creates a copy of the variable. It creates a new copy of the, it allocates memory and it creates a copy of the variable. Okay, so that is how even after casting we can use the original variable. So since static cast creates a copy of the variable, now we can understand this better. What will happen is that a new copy of B will be created. Okay, so a new copy of B is created and the new copies set function is called. So here we have a D object which contains a B object, as you all know. Now when I call the change function, a new B a new B class is created. I mean a new B object is created. And in the new object the dot set function is called with the argument 7. So in this case C is 7, so with the argument 7. So in the new object A is set to 7 plus 1, A is set to 8. Okay, but this does not change the value of A in the original object, right? So after this line, so originally as you can see A is 10 and B is 20 and then C is 10. So after this line A will remain 10. Okay, so after the first line A will remain 10 and B will change to C plus 1. Okay, B will change as it is because there is no casting or anything involved. So A will be 10 and B will be 8. So when we print this, we'll get 10 and 8. 10 and 8. So the answer will be 10 and 8, which is A. So so that's also. Anybody has any questions on this question? Okay, then let's continue to the last question. So this is the last question. It is similar to a question that you have done before, like previously. So please try first.
Sir, const cast.
Yes, you are correct. But there is another option also.
C style casting is also available.
Yes. So this is similar to one of the questions you did before. So here we have a class employee, which has two data members, string name and int salary, and there is a constructor which sets it, and there is a update function which updates the values of these, the name and the salary. But note that it is a const function, so it is not allowed to modify the values of the it is not allowed to modify the data members of the class. Then we have a show info function which is also const, and this function it prints the name and salary. It does not modify the function, so it does not modify the class, so this one is valid. Now in the main function we are constructing an employee, a constant employee. Okay, so we are constructing a constant employee with salary 3000 and name as Raj, and then we want to update it with salary 5000 and name as Rajan, and then we are calling show info, and we want it to print Rajan and 5000. Now ordinarily, since this is a constant object and the method is also const, so this line would not be allowed, and in the show info function it should print Raj and 3000. So to circumvent around the constness, what we can do is we can use the const cast operator to cast it to a non-const type. So we can use the first one. So this so in the object the type of this is employee star const. Employee star const this, and then we are using const cast, we are converting it to an employee star pointer. Okay, wait, so this is actually const employee star const this, and then we are converting it to a employee star const pointer. Okay, so we are removing the first constness. Okay, if you don't remember, the first constness prevents modification of the uh, pointy, so what the pointer is pointing to, and the second const it does not allow modification of this itself. Okay, so the the variable this cannot point to anything else. So with this const cast we are removing the, actually wait, actually yes, so we are giving a employee star as argument, so it will remove both the consts. Since we are giving employee star, it will remove both the const, so we'll get a employee star pointer. And since now it is now a employee star pointer, we can update the salary and the name. So this is one method to do it, and the other method, as you know, is the C style cast. Same way we can convert this pointer into employee star pointer. Okay, so any questions on question 10? Okay then, so that's all from me. So anybody has any questions outside of these sample questions? Okay then, so thank you for attending today's session. So this session is now over.
Thank you, sir.